Now, every time they removed a different portion of the brain, they discovered that they could never remove the memory of how to run the maze. They could impair the rat's ability so it might limp through the maze, but they couldn't remove it. And really, surgeons had known this for a while, doctors had known this for a while, because when people have head injuries, they don't forget half of the alphabet or half of their family or half of a novel they've read. They have global memory impairment where their entire memory may be hazy. But memories don't seem to be stored in our heads in the same way that books are stored on a shelf. And it wasn't until the 60s when Pribram encountered the holographic model that says that the whole is contained in every part that he said, aha, this may be what's going on in the brain. Specifically, because a hologram is made out of interference patterns, the hologram that you see, that we talked about earlier is made out of the interference pattern of laser light, but it can be made out of the interference patterns of any kind of energy, electromagnetic energy, electricity, X-rays even. And so Pribram said, since our synapses are constantly giving off electrical impulses, these are like proverbial pebbles dropping into the sort of electromagnetic pool of our brain. They're sending out ripples that are constantly crisscrossing. And he believes that's what the brain hologram, that's how we think and how we remember is through that hologram inside the head.
It would apply in another sense, too, because if you take a hologram image and cut it in half or in quarters or in tenths, each time you reduce it in size, the image becomes fuzzier and fuzzier, even though the whole image is there, just the way memory would seem to be. And
it becomes fuzzier when you have portions of the brain removed.
Yeah.
Correct.
And Pribram then also noticed that the same principle applied for visual information processing.
Well, yes, it's very interesting. He did not make the discovery, but he came upon the research done by other investigators. And that is another very interesting thing. As you know, Mother Nature uses all kinds of mathematical languages. When we go to understand physical phenomena, we generally find that there's some sort of mathematical underpinning to whatever the phenomena is. There are uncountable mathematical languages. It turns out that the mathematical language involved in the making of a hologram is a system of mathematics developed by a French man named Fourier. They're called Fourier transforms. Well, it also turns out that our brain uses Fourier transforms to translate visual information. And this is a very unusual state of affairs. It's kind of like discovering Eskimos speaking Spanish. It's not proof that the brain is a hologram, but it's suggestive that the brain is a hologram. And it turns out, in fact, all of our senses appear to rely on sort of Fourier transforms, that they all seem to use the same mathematics. So again, here's evidence that the brain uses the same mathematics to decipher the sensory world as are involved in the making of a hologram, which is, as I say, not proof, but compelling evidence that something is going on there.
Well, what this seems to suggest is a new way of looking at consciousness itself.
Very much so, yeah. It's an interesting thing. I have to say that I differ a little with Pribram, because Pribram thinks that the brain, as I said, that it's the electrical interference patterns in the brain. It is a brain hologram. I'm kind of a mystic because, at a young age I had an out-of-body experience where I left my body, and it became quite apparent to me while I was having this experience that I was thinking, but my brain was back in my body, which I could see in my bed. I knew it wasn't just a dream because I floated out over the ground outside my family's house, and I saw a book lying on the ground, and it was a book by the French short story writer Guy de Maupassant. And the next day, a neighbor said, by the way, Michael, I lost a library book by Guy de Maupassant. Have you seen it? And I thought, well, I floated over it last night. I didn't tell the neighbor that. But there was the book. And I was always I'm still very scientifically oriented. I want to understand the world in scientific terms. But it was really the first time that I sort of had to confront, the difference between my spiritual beliefs that we can survive, our bodily death, and this deeply held belief, scientific belief of mine that it's the brain that's doing the thinking. And I realized I had a kind of epiphany where I thought it isn't the brain that's doing the thinking. So I am not entirely certain that it's just the electromagnetic interference patterns that is the brain hologram, because those obviously would perish when the brain perishes. I think there might be some subtler level, some subtler energy that we haven't discovered with our technology that's involved in this also.
Well, Bohm's model is relevant and interesting at this point because he's not dealing with the universe as a hologram made out of electromagnetic interference patterns. He's looking at quantum wave potentials, which are at a much deeper level. And I must say, I've heard Pribram discuss it much the same way. There are quantum wave potentials in the brain itself, which is a much more deeply embedded level of energy and matter than the electromagnetic level.
Right. Bohm, it's a funny thing in science. The great physicist Herman Bondi called it the lure of completeness, that we tend, when we find some sort of outermost perimeter to what we can measure, we assume there's nothing beyond it. And I refer to it, it's kind of like in ancient times when we only knew a certain portion of the world, people always seem to say beyond the edge of the map there be monsters, that there was nothing there. And the same thing is going on in physics, that we have, with our technology, reached down to a certain level in reality, and it's a common prejudice among many physicists that beyond that level, there's nothing exists. There be monsters. There's just a void. Yeah. And it's an interesting thing that we, as I say, we have to have this lure of completeness. We have to feel that our knowledge of the universe is all that exists in the universe. Bohm, I think, is very wisely is one of the few physicists who comes out and kind of says the emperor has no clothes, says what rational basis to it? It's just prejudice that we assume nothing exists beyond this level of reality. Mm-hmm. And he feels that there are all kinds of domains of reality beyond this level, this microscopic level, and he theorizes that there may be untold, uncountable, subtler energies in these levels. The quantum potential is one. It's a theorized field that has not been measured or discovered with science, but Bohm feels there's evidence to posit its existence.
And it's now rather well accepted, I understand, among quantum physicists.
I wouldn't say that.
Oh.
No, it's pretty controversial, and the reason it's controversial is because the standard explanation of quantum physics has decided that this lure of completeness, that there's mm-hmm. nothing beyond. Yeah, the Danish physicist Niels Bohr, who's one of the founders of quantum physics, basically said you get down to a certain level of reality and things become blurry and you can't know anymore. Mm-hmm. And Bohm takes a very different route, which at this point is very sort of looked down upon by a lot of physicists, because most have been schooled in the way of Bohr's thinking.
Yes.
And Bohm, the quantum potential is not looked upon kindly by most physicists, I would say.
Well, I don't think we want to get into too technical a discussion of quantum physics at the moment, but I do think it's important to bring up the uncertainty principle, because in a way it's where physics comes full circle. And as I understand it, physics are saying, well, there may be all kinds of stuff, but we'll never know it because we interact with it. Anytime we attempt to look at particles beyond a certain level, the very act of observation changes things, mm-hmm. and that brings us to a point where we realize that the distinction between subject and object breaks down.
Right. But physicists get very funny about it. They get kind of schizophrenic because they'll openly admit that subject and object breaks down there, but they say that somehow this has no effect in the real world. Uh-huh. This does not translate from the microscopic level to our level, although there is a sort of creeping evidence in the scientific world that it does translate into our level. One obvious example, I think, that it translates into our level is that helium cannot be frozen solid. You can freeze hydrogen solid, you can freeze carbon dioxide solid, but helium, for helium to become its atoms to align in a solid form would violate the uncertainty principle, and nature doesn't seem to allow that. Mm-hmm. So you can't, no matter how cold helium gets, it remains a liquid. That, to me, if you can have a beaker full of liquid helium, and that exists at our level of existence, and it's a sort of manifestation of the uncertainty principle, and it's where it's sort of slipped over into our world. There are other things going on right now where there's a device called a squid, which is a sort of electrical coil in which it looks like we may be able to demonstrate that the current, if you say which direction is the current going in the coil, it's going both directions at once, which is kind of an impossibility, but to simultaneously do that too is a quantum phenomena, that these two realities are overlapping. So I think we will cross that barrier.
Well, I must admit, Michael, I'm not sure that I totally grasp the implications of those examples, but the examples I would like to focus on that do seem more relevant are the ones that suggest the enormous ability of the mind to affect systems in the body, the placebo effect, the work with healing and visualization. Mm-hmm.